Hello students, in this video I will go through an exercise on how to perform translations and glide reflections. And this is an assignment U2A02A, which is also taken directly out of our Envision text, the Envision text, which is our course text. Let's take a look. So in order for us to be successful at this assignment, we have to be familiar with the what it means to translate something. When we translate something, we're moving an object in the horizontal as well as in the vertical direction. And typically not typically, but the rule for translating something, say m comma n, via direction a comma b, the result is the image will turn out to be m plus a comma n plus a. In mathematics, we call this a vector, which is giving us a direction. Okay, that's all that is. It's a direction. Okay, which is why the notation here, if you notice, it's not a less than or greater than symbol. Rather, it's treated like an arrowhead. It's to re-emphasize to you that this is actually telling us a direction. Anyway, so what will this be? So the question here is asking us to figure out the image of x, y, and z after this translation. Well, x prime will then turn into 1 plus -4, that's -3. -4 plus -3, that's -7. Y prime will turn into -6 and -4. And z prime will turn into -6, -1 and -2. Okay, moving on. So again, question number 6, treat it the same exact way. I'm going to take x prime, and I'm going to add, not x prime, I'm going to take x, and I'm going to add 5 comma -3 to it, and that will give me 6 comma -7. Y prime will turn into 3 comma -4. And z prime will turn into 8 comma -2. What is the rule for the translation shown? So here all I got to do is just figure it out for one point, and it will be the same for all the other points. So that's how you can tell. This is going to be a translation of in the horizontal direction. We always list the horizontal direction first, not the vertical component. So we're moving 2, 4, 6, 7, I believe. Yes, 7 to the right and 3 down. Of quadrilateral ABCD. Okay. For exercise 8 and 9, write a composition of translations as one translation. So the way to think about this is, okay, when you are translating something over 2 different translations, so what you're doing is you're taking the point which was originally over here and you're translating it to get to 8 prime, right? And then you translate it one more time to get to, let's say, a double prime. So what all this is, okay, and if you think about it, I'm going to use a different color here, let's say blue, okay, to get from A to A double prime, all you got to do is go in just one big translation, right? And that is the sum of the y's and the sum of the x's. That's all that is, okay? So this actually turns into, it's going to be, well, remember, this is a composition of translations, right? So here really it doesn't matter, but we typically go from right to left. Remember that, okay? So we would translate -3 comma -4 first, and then 7 comma 8. But here we're just looking for the resultant. So 7 plus -3 is 4, and 8 plus -4 is 4. So we're translating this 4 comma 4. Same thing, we're translating 4 comma 6, and then via translation 0 comma 3. So this end result will be 4 comma 9. Number 10, how far apart are 2 parallel lines M and N such that I end up with this. So here, triangle JKL is translated 12, 0. Okay? And it says here that this is a composition of reflections. That this translation is equivalent to a composition of reflection. So if you think about this, if I'm translating something 12 units over, and just I want to make the statement before I give the solution. There's actually an infinite number of possibilities here. So let me explain that in a moment. But here, let's say I'm translating this 12 units, right? So what this means, okay, if I'm translating something 12 units over, okay, and if I'm performing a composition of reflections, okay, so what that means is I can perform a reflection, end up over here, and then I perform another reflection, and I end up over here, okay? So what could that be? So let's say if I go halfway, let's say I reflect something, let's say over R, I'm sorry. So let's say if this is RM, right, and this is R, a reflection over X equal to something, I want to end up at 6. Well, if I want to end up somewhere at 6, okay, I would have to reflect over, let's say, I don't know, let's say X equal to 3, right, because that's a halfway point. And then from there, now that I'm at 6, okay, I will then reflect this point over which other point to end up at 12. Well, this has to be N, right? So N would be, what would N be? Whoops, did not mean to do that. So N would end up being a line at X equal to, what's halfway between 6 and 12? That would be 9. So this would be R X equal to 9, okay, and that would be the reflection R3 R9 of triangle JKL. Is this the only way that that this translation could have been done? Of course not. Let's say if we didn't end up at 6, let's say if we ended up at 4 first, right? If that was the case, then there would be a reflection over line X equals to 2. And then from 4, I want to get to 12. Well, what's the halfway point between 4 and 12? That would be 4 plus 12 is 16, divided by 2 is 8. Okay? This is another way of getting there, okay? So either way, okay, we would have, with all these different possible outcomes, there's an infinite number of possible solutions here. This is just one of them. Okay? I'm sorry, X equals to 3. And this is going to be 9. Okay, moving on. For this question, it says that Hugo graphed triangle PQR and performed this composition, this glide reflection, right, translating and then a reflection of triangle PQR, where the equation of line T is y equal to 2. His translation and reflection were both correct. What mistake did Hugo make? So we translate 3, 1, right? So if this gets translated by 3, 1, and use red here to make it stand out a little more, Q would end up, where would Q end up? So we're translating 3, 1. That means Q would end up 3 to the right and 1 up. And then we're reflecting over y equals to 2. Q would then end up 3 below this. So that's where it would end up. Okay? It says here, his translation and reflection were both correct. What mistake did Hugo make? I don't see the translation and reflection as being correct, actually. I see the Yeah, I actually don't see the translation and reflection as being correct. So I'm opposed to this statement here that the text wrote. Okay? And then P, where would P end up? So if I translate 3 over and 1 up, P would end up over here. And then if I were to translate this, right? I mean, reflect this over line y equal to 2, where would it end up? 2, 4. I would go 4 below. It would be right here. This is where P would end up. Okay? Whoops. I made a mistake. 3 and then 1. That's where it is. And then Q, P prime would be over here. Okay? And then lastly, the R, go 3 over and 1 up. So R will be over here. R prime would be over here. So this is our triangle. That's what it should look like. Whoops. Okay. So actually, to answer this, it looks like what happened here. It looks like the person, Hugo, performed a reflection, and then after the reflection, performed a translation that was not 3, 1, but 3, -1. No, I take that back. He performed the the glide reflection backwards. Okay, so he performed. So Hugo, this is it. Hugo performed the composition in reverse. First reflecting, so he did this. To triangle PQR. So remember, we're always going from right to left, not left to right. Okay, so that's the mistake that he did. Okay. How can you describe the complete transformation to a person who cannot see the transformation below? So I have the image right here. This is the red is the final image. So there was a reflection first that was performed. So there was a reflection. There was a reflection over the line x equals to 2, followed by, it looks like there was another reflection that took place at x equals to negative 1.5. Of triangle ABC. And this is actually equivalent to just one direct translation, but that's not what they're asking for. They're asking you to describe what took place here. Okay. And then for number 15 to 17, it says, give the coordinates of the image. So this one right here is really, really similar to the examples that we did in the beginning of this assignment here. So A prime, all I got to do is just add the vector 3, -1, and that would be A, -1. B prime would be 2, +1. C prime would be 9, -4. Moving on here, D prime would be -1, 3. E prime would be -6, 3. And F prime would be -4, 2. And lastly, G prime would be -10, -5. H prime would be -7, 1. And j prime would be 2 comma negative 6. What is the rule for the rigid motion? The rule for the rigid motion here is we are performing a translation. So if you go from here to there, right? So that would be a translation of, let's see, 2, 4, 5. So it's negative 5, comma, and we're going to go up, so up 3 of triangle ABC. 21 to 24, write each composition of translation as one translation. So this is going to be, we're just going to add the components of the direction here. So this is negative 5 comma 7. Question 22, this is going to be negative 1 comma negative 2. Question 23, this would be negative 2 comma negative 1. Question 24, this would be equivalent to 4 comma 7. Again, I'm only adding the components here. The x's with the x and the y's with the y's. All right. So for examples 25 to 20, exercise 25 to 28, write each composition of reflections as one translation. Suppose K is the line with equation x equals to negative 3, L is the line with equation x equals to negative 2, M is the line with equation x equals to 1. I'm not going to remember any of this, so I'm just going to skip ahead. It says right here, it says to write each composition of reflection as one translation, right? As one translation. So here, this is equivalent to reflection of, what was K again? K was x equals to negative 3. And what was L again? L is x equals to negative 2. So if I were to perform this as one translation, so negative 3, reflect something over the line x equals to negative 3, and then again at negative 2. So what would that be as one equivalent translation? So that would be equivalent to, let's say if I take point the origin, okay, and I reflect it over x equals to negative 2. If I do that, I'll end up at negative 4. And if I reflect negative 4 over line x equals to negative 3, I'll end up back at x equals to negative 2. So that would be a translation of negative 2 comma 0. Right? So one more time, if this is x is equal to negative 2 and this is x is equal to negative 3, if my original point was at 0, 0, if I reflect it over line x equals to negative 2, I'll end up at x equals at negative 4 comma 0. And if I reflect negative 4 comma 0 over line x equals to negative 3, I'll end up at negative 2 comma 0, which is a translation of just negative 2. Okay, M and N. So what exactly is M? M is x equals to 1. And what is N? N is x equals to negative 1. So again, if I perform this very similar process, if I'm at 0, 0, if I reflect over a line x equals to negative 1, I will end up at negative 2 comma 0. And if I take negative 2 comma 0 and reflect it over a line x equal to 1, I will be at, so Negative 2 comma 0 is 3 away from 1, so that means this is going to be 4 comma 0. So that means I'm going to be translating a total distance of 4. And what is P and Q? P is y equal to 1. And Q is y equal to 3. So similarly, I can make a very similar kind of process here. I want to draw where there's space because I'm running out of room really fast. Y equal to 1 is here, and y equal to 3 is up here. And if I were to reflect 0, 0 over y equal to 1, and then y equal to 3, I'll end up at 2, right? I'll end up at 2. So this will be 0, comma 2, and then reflect 0, comma 2 over line y equal to 3, I'll end up at 0, comma 4. So I'm translating this 0, comma 4. And then repeat. Reflect t. What is t? T is y equal to negative 4. And what is s? S is y equal to 2. Y equal to 2. S is equal to y equal to 2. So again, if I go through this, y equal to negative 4 is down here, and y equal to 2 is up here. If I reflect this, that means I'm going to be somewhere down here, which is going to be 0, comma negative 8. And then I'm going to take this, that's going to be 10 away from y equal to 2. I'm going to be, it's going to be 12. So this is going to be a translation of 0, comma 12. And that's it.